So this is the introductory video for the course Phase Equilibrium and Materials, which is the second part of the module, second module of the course on nature and properties of materials. In the first part, we looked at structure of materials. Now we look at how different phases in different material systems they coexist with each other. So we'll begin with a short introduction to the thermodynamics, whose knowledge is essential to understand the phase coexistence, and then we will look at how the equilibrium is possible to exist in multi-phase systems or multi-component systems, and which will bring us to the understanding of phase rule, which can be applied to variety of phase diagrams, and we look at how it is done. And then we will look at a variety of phase diagrams, starting with unary phase diagrams or single component phase diagrams, moving on to binary phase diagrams, where we will try to first understand how the phase rule can be applied, then how different phases coexist with each other, what is the method of calculating quantitatively their proportion with respect to each other, their compositions, and so on and so forth. And in very brief manner, we will also look at ternary phase diagrams, which could be quite common in applications in systems where more than two elements coexist with each other. In fact, one can go on to even quaternary and pentanary system, but that is out of scope for this course. And then we will look at some common alloy systems whose phase diagram we will discuss, such as iron carbon phase diagram, which is a very important phase diagram because it concerns the steel and cast iron, one of the two most used materials in industry. And finally, we'll look at the correlation of phase diagram with how the microstructure in material evolves, which is very important. So in a nutshell, this course will give you information on how phases coexist with each other under a given set of thermodynamic parameters in various material systems. And this is a useful course not only for second year or third year undergraduates of material science and metallurgy. It is useful. It is probably going to be useful for general students of mechanical engineering, chemical engineering, or even other branches of engineering, who want to work on materials but do not have full-fledged knowledge of materials. And this course will strive to, or even physics background, chemistry background persons. So all you require is basic knowledge of thermodynamics. So if you have done some thermodynamics at the level of 12th, that should be sufficient to take this course up. Thank you.